Hello.
Hello, Rahul. Can you hear me?
Hi, sir. Yeah, I can hear you, sir.
Hi, Rahul. Okay. So, what's going on in college? Any updates?
No, sir, no update. Just no regular lectures going on, sir.
So, exam is on 15th, Friday,
No, sir, it's on 19.
Tuesday.
Yeah, Tuesday, correct.
Okay, that works. So, Rahul, any doubts on the logistic regression part that we focused on? The discriminating power and the AIC and BIC. Does all that make sense to you?
Yeah, sir.
Okay. All right. So, if that part is fine, Rahil, then I think today will be a little bit smooth for us because we are going to discuss the other models that we have for classification purposes. Okay. One of them was the logistic model, right? Like I was explaining. So if you have your y variable as a 0, 1 classification variable, then one of the models that you can use for classification purpose is your logistic model, right? Remember that part? So there are other
Yeah.
possible models as well. We are going to discuss the others that are mentioned in your slide, right? So let me start today with the Probit model.
Okay.
Okay, so your basic data is the same. So you have a binary y variable and a continuous x variable. All right. So we'll keep that structure same.
Okay. So we did logic. Now we're doing probit.
Exactly. Probit. Yeah, we are done with logic. Now we are doing probit, right?
Okay.
So probit model. So the data that we have is that my yi's can be either zeros or ones, and xi's can be any real value. Okay, this is my sample data. All right. So based on this, I want to use a Probit model for estimation purposes. So the idea of the Probit model is that, so as per the Probit model, the conditional probability that we take, probability that yi is equals to 1 given xi, which we will denote by pi, is nothing but cap phi of beta naught plus beta 1 xi. Okay, right? Where what was cap phi is the CDF of the standard normal distribution. Okay, is the notation making sense to all of you, right? Is it
Yes.
fine? The notation.
Yeah.
So what was the CDF if you remember? So here, let's say for example, if I have to find out the cap phi CDF at a point like K, then we were basically trying to find out the probability that the random variable will take a value less than equals to K, right? Correct?
Correct.
And that
Correct.
was by definition, sorry, the for standard normal we use the notation Z, not so that is integration from minus infinity to k 1 by root over 2 pi e to the power minus of z square by 2 dz. Correct? So that means here what will be your cap phi of beta naught plus beta 1 xi, it will be integration from minus infinity to this value is it. Okay. And just one more thing, I would just like to write it over here in the beginning. So the PDF of the standard normal is denoted by phi of z, right? The CDF is cap phi and the PDF is phi. Okay.
Yeah.
Okay then.
Yeah.
And this also, if you are trying to plot it
So,
graphically, huh,
can you say that again? The PDF and CDF. What is it?
the cap phi notation
Yeah.
is for
CD.
CDF, and
Okay.
this phi notation is for PDF of
Okay.
standard norm. Okay, notations specific to the standard normal distribution. Okay, got it.
Sorry, sir. I was on mute. Yes, I got it.
Okay.
Yeah.
So this also, so my curve that we are using to fit the data will once again be the sigmoid shape. Okay, so if I'm trying to plot, horizontal axis पे हमारे x size है और vertical axis पे we have our yi values, right? Now yi's can take only two possible values. For some values of x, it will be 0. For some values of x, it will be 1. Correct?
Okay.
So the CDF, because it's a CDF, it will also have this kind of a shape. Alright. So that is why we use this for probability modeling. Okay.
Yeah.
That's the idea. So this is my Probit model. So over here, that means if I tell you to write down the Probit model, it is basically this.
So, like, for
Hmm.
the Probit and Regression model, the value, like the equation that we have written, like uh, CDF of this beta plus beta I x I, 1 x I, like where it comes from, is that important, or should we just like know that it is this?
Which one? Where it comes from?
So, like for Probit, like
Ha ha ha.
you just wrote like it's the CDF of beta naught plus beta 1 x1. So, like we just need to know that, right?
I'm not able to follow Rahil. Are you asking कि हम लोग standard normal क्यों ले रहे हैं? Is that the reason why you're asking? और ये expression ऐसा क्यों दिखता है? Which one is the question?
The latter, like not standard normal, but why are we doing beta naught plus beta 1 xi ka
On
CDF?
as the upper limit of the integration.
Yeah.
CDF कैसे निकालते हो? For any
So,
probability distribution?
no, so I'm not asking that. Like, why
Then
are we taking that value?
Okay, why am I taking beta naught plus beta 1 xi, right?
Yeah.
Okay. So the idea is that I want to assume that the probability depends upon xi, right?
Right.
Okay. So I take that in a linear format. The relationship is beta naught plus beta 1 xi. That's it. जैसे if I have to do a simple linear regression model, I think we discussed this yesterday as well. कि अगर I talking about a relationship between variables y and x, this is the relation that you take, right? If you have
Right.
to establish a relation between x and y, this is how you take it. So now, instead of finding a relationship between y and x, I want to find a relationship between pi and x. अब pi को तो directly beta naught plus beta 1 x नहीं लिख सकते, right? Pi has to be bounded between 0 and 1. So that is why
Mhm.
I use a
Oh.
function that ensures that the functional value of beta naught plus beta 1 xi will lie between 0 and 1. Okay.
Oh.
In your slides, you will find this term used quite often, that this is known as the link function. Like
Hmm.
I was telling you, कि ऐसा मैंडेटरी नहीं है कि लॉजिस्टिक यूज करना होगा या स्टैंडर्ड नॉर्मल का सीडीएस यूज करना पड़ेगा. You can ideally use any function that ensures that it will always be bounded between 0 and 1, right?
Yeah. Yeah. Yeah.
That
Okay. Okay,
kind of
sir.
a function you can use for logistic and sort this kind of a model, right? Okay.
Uh,
So the probability is this. Okay. Probability of the event occurring is cap phi of beta naught plus beta 1 xi. Okay. That is the idea. All right.
yeah.
Now is it making sense? Now
Yes,
is
sir.
it
Making.
fine, right? Okay. Okay. So it is the structure that you write to establish the relationship. That is the only thing. Okay.
Okay.
All right. So now once we are done with the structure of the model, कि Probit model कैसा दिखेगा, the next thing that we need to do is that how we are going to estimate the parameters of the model, right? Correct?
Yeah.
Estimation. We are understood the structure or uska properties. Next comes the estimation of the model. All right. Now, once again, PIs are not known, right? Although you are modeling probability, but the actual probability values are not known.
Yeah.
So, यहाँ पर भी we will not be able to apply the OLS, right? So, OLS cannot be applied.
Right.
So, what we will use? MLE, right? So, for that, we first define the likelihood function. L is equals to product of I running from 1 to n, pi raised to the power yi, 1 minus pi raised to the power 1 minus yi. Correct?
Hmm.
So from here you will have your log likelihood, which is small l, जो मेरा function होगा beta naught और beta 1 का. So that will be summation I running from 1 to n yi log pi plus 1 minus yi log of 1 minus pi. Correct?
So why would one minus y one? Is it why is it one?
So let's say
Shouldn't it n like?
नहीं 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 n नहीं होगा.
This is Bernoulli.
Okay.
This is
Yes. Yes.
okay. Okay. So
Directly,
then
right? Yeah, this is Bernoulli only, right? Because any bivariable can have two possible outcomes, 0 or 1. Correct.
okay.
And the
Understood.
probability of getting yi is 1 is pi. Correct. So each of the yi's follow Bernoulli with pi's.
Okay. Understood.
ठीक है?
Yeah.
It's not that all the y's have the same probability, right? It depends on x. That is what we are trying to establish. So इसीलिए pi. So each of the yi's are a random variable that follows a Bernoulli distribution with probability pi. All right.
Got it.
So your likelihood function L of beta naught and beta 1 will become summation of I running from 1 to n yi into log of pi. Pi is what? Cap phi of beta naught plus beta 1 xi. करेक्ट? इसको और सिंप्लीफाई नहीं कर सकते. प्लस 1 माइनस yi log of cap phi beta naught plus beta 1. ओके. तो लाइक्लीहुड के लिए क्या करते हैं? We have to maximize the likelihood function. So del L by del beta naught is equals to 0. Maximize it with respect to beta naught and beta 1. And del L by del beta 1 is equals to 0. Right? So
Yeah.
what will this happen, right? If you just take a look at the calculation as well. So this will become summation I running from 1 to n yi. So 1 by cap phi of this जो है, correct, into, क्योंकि बीटा नॉट तक जाना है तो बाय चेन रूल डेरिवेटिव ऑफ द CDF इज द PDF, राइट, into डेरिवेटिव ऑफ बीटा नॉट प्लस बीटा 1 xi जो कि होगा 1 बिकॉज ये डेरिवेटिव विद रिस्पेक्ट टू बीटा नॉट प्लस 1 minus yi into log का डेरिवेटिव will be 1 minus this, 1 minus cap phi of this into 1 minus cap phi का डेरिवेटिव, so that will be minus phi of this into derivative of beta naught plus beta 1 xi, which is 1.
Yeah.
Check this, Ryle, if this is making sense to you.
Yes.
Okay. Moving on to the next one. Summation I running from 1 to n. Beta 1 tak jana hai, so the first few steps will be same. Yi derivative of this is 1 by cap phi of this into cap phi ka derivative, which is phi of this into derivative of beta naught plus beta 1 xi with respect to beta 1. तो ये होगा सिर्फ xi plus 1 minus yi into minus phi of this into xi is equals to 0.
So this is a chain rule, no?
Yes, chain rule. देख लो if it's
So
making
how
sense to
does
you, otherwise.
just one
हाँ,
question
कौन
like
सा?
so like for example the first second equation yi into 1 divided by the CDF into that variable. How do we get that? Sorry, the PDF. Yes.
So, okay, so we are talking about the derivative of this, right?
Oh, so the derivative of CDF is the PDF.
Yes, correct.
Okay, understood. Okay, so understood.
Understood? Okay, chalo.
And then after the derivative, we also again we do it, and then we get into xi. So that's chain rule again.
Yes, because you have to reach up till beta 1, right?
Yeah.
So first of all is the log, then is the cap phi, then is the beta naught plus beta 1 itself. Right? So
Okay.
if I just clean up a little bit, so what are my normal equations? Right?
Yeah.
Correct.
Yeah. Got it.
Okay. So this is your equation 1. And what about the second one? So this will become summation I running from 1 to n cap phi of beta naught plus beta 1 xi into xi. This will be outside minus of 1 minus yn is equals to 0. Correct. So two
Yeah.
equations to solve for beta naught and beta 1. Right? Correct. Now,
Yeah.
interestingly, Rahil, one more thing, जो शायद I had told you once, long time back, that these two are not linear equations, right? It is equation in beta naught and beta 1, two equations to solve for two unknowns, but these are not linear equations, right? कि matrix rule या कुछ
Right.
लगा के you can find it out. So we have to
Mm.
use obviously two equations to solve for two unknowns, but ये directly नहीं निकलेगा. These two equations have to be solved numerically to obtain the values of beta naught and beta 1. Numerically matlab you understand? Numerical method matlab?
Yeah.
Okay. So you need to use some numerical method, or usually when we are talking about R or Python, जो default numerical method जो use होता है is Newton-Raphson. I don't know if you have heard the name of it. It's a method जो basically एक loop में चलता है and it tries to have different values of beta naught and beta 1 in such a way such that both the equations are satisfied. Okay, it's a iterative process. एक loop में तुम feed कर दो and it will run accordingly. All right.
Hmm.
So equation
Got it.
1 and 2 are solved numerically to obtain beta naught hat and beta 1 hat. Okay, that is the
Yeah.
idea. And once you have obtained beta naught hat and beta 1 hat, what are your estimated probabilities? Pi hat will be cap phi of beta naught hat plus beta 1 xi. Okay,
Yeah.
ठीक है, got it? So these are your
Got it.
estimated probabilities. अब अगर goodness of fit decide करना है तो what we'll do? First of all, overall model का fit decide करने के लिए we'll use the AIC or BIC. And then if I have to decide that how good is the discriminatory power of the model, I will draw the ROC curve and calculate the AUC. याद है? The process that I was discussing in the last class. The same thing
Yeah.
can be applied over here as well, right? It is just that you are using a different model to estimate the probabilities. But once the probabilities are estimated, the same process will follow for assessing the goodness of fit. So for
Yeah.
goodness of fit, two steps for overall goodness of fit. Assessment हम लोग यूज करेंगे AIC या फिर BIC, right? And lower the value of AIC or BIC, better fit is the data. Right, right? Agreed? Can you recollect this?
Yeah.
And
Yes. Understood.
for calculating the discriminatory power, obtain the AUC under ROC, right?
Right.
Where your AUC must belong from 50% to 100%. And higher AUC, more the discriminatory power. Okay, all right.
Yeah.
So we have understood how what is the basic structure of the Probit model, how we are going to estimate it, and how we are going to assess how good the fit of the data is, right? यही तीन steps होते हैं, right? कोई भी model building exercise के. First of all, the structure, then the estimation, and then assessing how good the fit is.
Yeah.
Okay, perfect. Moving on to the next one. तुम्हारे स्लाइड में और एक मॉडल डिस्कस हुआ है, so let me pull that up as well. So now that you have at least got the overview कि हम लोग कैसे डिस्कस कर रहे हैं, so let me discuss this straight away from your slides. ठीक है? So this is your lecture 5 का slides that I am referring to. Okay?
Okay. So till now we have been
Uh,
doing 6 or 5 or both.
Actually, we are doing both of them together. ठीक है, लास्ट डे जो
Oh,
AUC ROC वाला part that I discussed, that is there in 6, right? Like I told you कि I didn't just
yeah.
want to go through the models one by one and then go for it. I just thought कि एक model में ही if you understand the entire workflow, the other models will be simple to understand, right? कि एक model के साथ करना क्या क्या है. By workflow, I mean that only. I need to
Hmm.
understand the structure of the model. I need to understand how to estimate the model. I need to understand how to interpret its parameters. And I need to understand how am I going to assess the goodness of it. यही तीन चार steps करने होते हैं, right? Okay.
Right. So
So this is the next model that we are taking up, which is the binomial and proportional responses. Okay. So let's go over this slide one by one. So what does it say? That suppose we observe more than one binary outcome for each combination of predictors. Okay. The response becomes more than simply binary. That is, we have some number of type and some number of other type. In such situations, we have a binomial rather than just a Bernoulli distributed response. Okay. So suppose the response yi for I equals to 1 to n is binomially distributed with probabilities mi or pi I, so that the probability yi is equals to small yi is this. Okay, mi c yi pi I to the power yi into 1 minus pi I raised to the power mi minus yi. We further assume that the yi's are independent and the individual trials that compose yi are subject to the same q predictors x1 all the way till xq. Okay. Is this making
okay.
sense to you, Rahil? Anything that is not understood from here?
Making sense.
Making sense? Okay. So
Yeah.
in this case, you can have in not only 0 and 1 but multiple possible values, right? That is what we are talking about. Okay. So this one more addition over here, Rahil. So अगर मैं small yi के values का बात करूं, then what are the possible values? It can take 0, 1, 2, all the way up till small mi, right?
Right.
If your yi variable is binomial mi comma pi I, then your small yi can be anything between 0 to mi. Okay. So we are saying that instead of only 0, 1, if you have multiple possible outcomes that are there, then in that case it will be a binomial distribution instead of a Bernoulli. ठीक है, अब तक लॉजिट और प्रोबिट दोनों केसेस में बर्नोली था, राइट? योर y वेरिएबल वाज बर्नोली, है ना? वेयर इन द केस ऑफ लॉजिस्टिक you were modeling your probability of Bernoulli using the Probit model, and in Probit model you are modeling the probability of the Bernoulli using the Probit regression, right? Probit function basically.
Yeah.
Agreed, right? Perfect.
Uh,
So if this
yeah.
is the case, yeah, moving on to the next slide that is given in this context. So as in the binary case, we construct a linear predictor in this way, which is eta I is equals to this. We can use the logistic link function, which is log of pi I by 1 minus pi I, and then the log likelihood is given by this expression.
Right.
Okay. So what are we doing? कि ये जो पाई आई है that we are modeling using logistic. Okay, so if we are doing this, then this is how your log likelihood looks like. और फिर यहाँ पर भी we will have the set of unknowns. Correct? अच्छा, for
Yeah.
this let me just write this once. I think ये वाला थोड़ा सा it would be helpful if I write this. So we have our yi's are binomial distributed with mi comma pi I, right?
Yeah.
N observations yi. That means the probability that yi is equals to small yi will be mi c yi pi I to the power yi 1 minus pi I to the power mi minus yi, where your yi can take values from 0, 1, 2 all the way up till mi. Okay, and here your pi I is basically e raised to the power beta naught plus beta 1 x1 I all the way up till beta p xpi divided by 1 plus e to the power beta naught plus beta 1 x1 I plus all the way up till beta p, है ना?
Yeah.
Correct. So in order to model the probability, I am using the logistic function, या फिर जैसे कि तुम्हारे slides में कहा गया है, I am using the logit link function. Okay. So that means from this data हमारा likelihood कैसा होगा राइट? L, which is a function of beta naught, beta 1 all the way up till beta p, will be product of I running from 1 to n mi cyi pi I to the power yi 1 minus pi I to the power mi minus yi. हो गया? और फिर यहाँ से log likelihood, which is small l as a function of beta naught all the way up till beta p, which is summation I running from 1 to n log of this combination plus yi log of pi I plus 1 minus pi I log of 1 minus pi I. ठीक है?
Yeah.
Okay. And then it is the same kind of calculation that we have. So should we work that out, right? Or you can manage?
So I can manage.
You can manage? Okay. ठीक है. So from here, there will be कितना parameters है? P plus 1, right? P slope
Yeah.
coefficient and 1 into. So P plus 1 normal equations and then we need to solve it. ठीक है. Fair enough. Alright, so this is about the binomial proportion जहाँ पे it is basically more than 0-1 classification. You have multiple possible cases. Okay. So basically हमारे पास अभी तक 3 models है. One is your logic, one is your probit, and then this is the binomial model. Alright, 3 models that are discussed in your fifth lecture. Okay, or sixth lecture ka we have already understood the basic idea of how we are going to judge the goodness of fit, ROC and AUC wala model. And then what else remains?
So, how much of the 5 and 6 have we finished? Like, just to understand.
Five we have covered fully, and six, 50%.
Okay, okay.
Okay. Rahil, tell me one thing. When these slides are discussed in your class, do they
Yeah.
only discuss it at the example data sets that are given, or do they discuss it like independent of that?
So I didn't get it. Meaning, so like,
Like basically, do they discuss it? Do the is the discussion only through कि हाँ ये data है इसको ऐसे estimate करना है and we are getting this? Is it only around or is it more theoretical like what I am discussing basically?
some proofs that you're doing, he does it in class, but it's not important. Um, so like the proofs we can skip also, but yeah. But apart from that,
Skip.
it's it it's mostly like application only. So like the examples and everything.
Okay, but okay, ठीक है. I understand what you're saying.
Yeah.
Okay, but I think without a little bit of this, things don't make much sense.
Without what?
ये
So.
काम
Yeah, yeah.
without a little bit of the background understanding कि ये कहाँ से आया. Otherwise, they just
Uh-huh.
look like some bunch of equations just landing onto
Mhm.
your slides, right?
Yeah, that is so.
Okay, okay, all right. So the next part of slide 6 has something a little bit of more interesting over here, which is the part on क्या कहते हैं इसको model validation and calibration. Yes, model validation and calibration.
Okay.
This one. Okay. Now Rahil, just remember one thing जो मैंने तुमको एकदम स्टार्टिंग में बताया था कि why do we build these models? To make predictions, right? Correct?
Yeah.
And we had taken this example of a bank, right? Who is trying to build a model of assessing the probability of default. कि if a new client is coming with so and so X variables ka values, then whether the loan can be approved or not, right? Whether the client will default or not.
Right.
Okay. So now understand this, Rahil, that अभी तक हमने जो डिस्कस किया है आई हैव माई डेटा जिसके ऊपर आई एम फिटिंग द मॉडल एंड आई एम ट्राइंग टू असेस हाउ गुड द मॉडल is on the data that we have chosen, right? Correct.
Yeah.
But if you go a little bit elaborately, one more step, so to say, application perspective say the model should also perform good on out of sample observations, है ना? Like for example that you have some pool of clients जिनका data use करके you have built out this model, correct?
Right.
Tomorrow you will get a new client with some different set of x variables, right? Not very different, similar, but obviously it will not be कि कोई एक client के साथ पूरा match कर जाए, right? So the
Yeah.
model that you have already built, it should be able to give good predictions for this new client, है ना? Only then can you say that your model is useful or meaningful, है ना? So
Yeah.
model validation is a different exercise altogether, राहुल. अभी तक हम लोग जो कर रहे थे that was model building, कि हमें कैसे इसको build करना है, what should be the methodology, how to assess कि वो model सही से fit हुआ है कि नहीं. The next part of the story comes when you are trying to apply the model, and here you will try to assess that how good is the model to some out of sample observations. ठीक है, वो डेटा पॉइंट्स के ऊपर तुमने मॉडल बिल्ड नहीं किया है, बट यू हैव टू असेस कि वो डेटा पॉइंट्स के ऊपर मॉडल कैसे परफॉर्म कर रहा है. ऑलराइट,
Understood.
समझ? सो दैट इज व्हाट वी कॉल इट एज वैलिडेशन. ऑलराइट, so the first thing to distinguish is that validation is mostly done on a different data set altogether, जिसको हम लोग कहते हैं, it is mentioned in your slides over here, टेस्ट सेट. जिस डेटा सेट के ऊपर मॉडल बिल्ड होता है उसको हम लोग कहते हैं द ट्रेनिंग और द लर्निंग सेट. ठीक है, द मॉडल इज एबल टू discriminate between good and bad observations based on the data on which it is estimated. Okay, so that is its learning set. Now once it is able to have some meaningful discrimination, discriminatory power, we try to see कि क्या वो फ्यूचर ऑब्जर्वेशन या एलियन ऑब्जर्वेशन पे भी सही से डिस्क्रिमिनेट कर पा रहा है या नहीं. ओके, ऑलराइट, सो दैट एक्सरसाइज इज व्हाट वी कॉल इट एज मॉडल वैलिडेशन. ऑलराइट, समझ गए? सो
Yeah.
लेट्स से दैट आई हैव अ ट्रेनिंग डेटा.
Okay.
ठीक है, जिसका साइज है n. Based on which I fit the, let's say, logistic regression. ओके, लॉजिस्टिक रिग्रेशन अगर मैं फिट कर दूं, I will obtain the estimated parameters once you fit it.
Yeah.
Okay, and from here हमारे estimated probabilities calculated कैसे होंगे? Pi I hat is equals to p raised to the power beta naught hat plus beta 1 xi. Agreed? Now what do? You give, तो ये हमारा आ गया, राइट? हमारे एस्टिमेट्स आ गए और प्रोबेबिलिटीज ऐसे कैलकुलेट होंगे, ये हमें पता है. दिस इज द मॉडल डेवलपमेंट स्टेज. अब लेट्स से इफ आई गिव दिस, इफ आई यूज सम फॉरेन डेटा जिसको हम लोग कहते हैं टेस्ट डेटा, जिसका वाई हमें पता नहीं है. ठीक है, these are future events.
Hmm.
All the way up till x of let's say n plus k. तो मेरा जो टेस्ट डेटा है इसका साइज इज k. ठीक है, नाउ व्हाट डू आई वांट टू चेक कि ये जो मैंने डेटा दिया है उसके बेसिस पे जो निकला प्रोबेबिलिटीज, हाउ एक्यूरेट आर दीज वैल्यूज. ओके, समझ गए.
Yeah.
So this is what we will discuss in the next class under model validation. Once you have obtained the estimated parameters and know the functional form जो हम लोग use करेंगे to calculate the probabilities, how we can validate the model for good prediction purposes. ठीक है, what are the techniques that we use. ठीक है, right? समझ गए. This is our
Okay.
content for the next class. All right, so let's stop here for today. हम लोग validation part से next class में continue करेंगे. All right, चलो.
Uh, so I had like one question. So very
Yes.
like a stupid question, but so like when it comes to p-value, okay. Um,
Okay.
so like when we calculate p-value, uh, like the so for example, let's take like we want the probability of a dice rolling greater than equal to 3. So uska p-value that will do so like we'll get a large p-value. So we need a large p-value or a small p-value to reject. Like I'm getting confused in that concept, so. So like if we need to calculate this, it will be the probability of getting 6, 5, and 4.
So reject what? So what is their hypothesis in this example?
Uh, so you only given any hypothesis, like it's fine. Like if the okay, so wait, let me just get an example actually.
Okay, don't take this example. This is confusing.
Okay.
Take a simple mean ka hypothesis. So suppose you have a random sample. Let's say normal mu comma 1 variance known. Okay, and your
Okay.
hypothesis is let's say greater than 10.
Yeah.
Okay, तो हमारा टेस्ट स्टैटिस्टिक क्या होगा? एक बार माइनस म्यू divided by sigma square, which is 1 by root n, which under the null hypothesis will follow normal 0 1.
Yeah.
Correct.
So can we do like that? Like when we find the probability of an event happening greater than equal to some set value.
हाँ वही कर रहे हैं, वही करने वाला.
Okay, sorry, sir.
So मेरे टेस्ट स्टैटिस्टिक का डिस्ट्रीब्यूशन विल बी नॉर्मल 0 1. करेक्ट. अब देखो p तो for testing of hypothesis you fix a significance level, right?
Yeah.
Let's say alpha is 0.05. All right, so
Yeah.
because this is right tail test, 5% will be over here. This will
Yeah.
be your 5%. Okay. And the 5% value for standard normal is 1.64. अब
Huh.
देखो, based on the random sample that you have, you will get your t observed, right? The observed value of the test statistic.
Okay.
Correct? Now
Okay.
think of it. अगर मेरा t observed 1.64 से कम हो, then I am closer to the null hypothesis. So I will
Hmm.
accept it, right? So this part is accept H naught, correct? And
Correct.
if
Correct.
my observed value is beyond 1.64, then I will be rejecting H naught because वो 0 से बहुत दूर जा रहा है,
Correct.
correct? That
Yeah.
is the idea. Now, if you have to visualize this in terms of p-value, p-value ka definition in this case will be the probability that the test statistic will take a value more extreme than what it is actually observing. This is your p-value.
Yeah. So like
Okay.
let's give this a value, for example. Like just give it a
Hmm.
number, for example.
So मान लो कि मेरे ऑब्जर्व टेस्ट स्टैटिस्टिक का वैल्यू, सो बेस्ड ऑन तुमको जो रैंडम सैंपल तुम्हारे पास है, यू
Huh.
ऑब्जर्व दिस वैल्यू टू बी 2.
Yeah.
ओके. So in this example, I want to find out the probability that the test statistic will take a value more than 2. So मेरा 2 इधर होगा,
Huh.
right? So the
Yeah.
probability that t will take a value more than 2 will be this area.
Right.
So this will be your p value.
So what will the p-value be here? Like something like very high,
Less
no?
than 0.5. नहीं, less than 0.5, right?
Okay.
T greater than this. So t greater than this मतलब क्या? The area under the curve to the right of 2. तो अगर ये एरिया 5% है, एरिया टू द राइट ऑफ 1.64, then the area to the right of 2 will be less than 5%.
Hmm. Okay.
Correct. So that means if the p value is less than 5%, you are still in the critical region and you will reject your null. क्योंकि अगर ऑब्जर्व वैल्यू अगर यहाँ पे होता, फॉर एग्जाम्पल दिस वन, देन यू आर इन द एक्सेप्टेंस रीजन, राइट? तो अगर तुम p वैल्यू कैलकुलेट करते, ठीक है, मान लो, सो दिस इज योर रिजेक्शन रीजन में है, राइट, p वैल्यू.
Okay, sir, understood. So now, for example,
अंडरस्टूड?
that blue thing, like where you're marked, okay, for example, we
यस.
get for point 4, for example. So that,
0.45. ओके, ठीक है, हाँ.
yeah. So now, like we are saying, like under the null, like 45% chance है कि ये होएगा.
नहीं
Uh,
नहीं,
then what
you
are
are
we?
talking about the 0.45 is what? The value of the test statistic you meant, right?
Oh, sorry. No. Yeah, okay. For example, test statistic is 0.45 and we get a p-value of um like 0.33, for example.
नहीं आएगा, कैसे आएगा?
So okay, so just
p
give
वैल्यू p वैल्यू p p वैल्यू कैसे निकालोगे? अगर तुम्हारा observed,
हाँ,
in this example, if your observed test statistic is 0.45, then
yeah,
इस ऑब्जर्वेशन के लिए p वैल्यू क्या होगा? इट इज द प्रोबेबिलिटी दैट t इज
हाँ,
ग्रेटर देन 0.45.
right,
तो
right,
अगर 1.64 से ज्यादा 5% है, देन 0.45 से ज्यादा मतलब क्या? वी आर टॉकिंग अबाउट दिस एरिया. तो ये तो
yeah.
5% से ज्यादा ही होगा, तो 0.63 कैसे आएगा?
Point 33, sir. I'm saying like 33%.
33? अच्छा, 33%. ओके, हाँ, ये आ
Yeah.
सकता है.
So like what is the interpretation of that? Like उसका
So
मतलब
the
क्या होता है?
probability, the probability that the test statistic will take a value more than 0.45 is 33%. ठीक है? That means the probability that the test statistic will take a value more extreme than what you are actually observing is 33%.
Right. So then we do not reject it.
Yes, we do not reject it.
But sir, if there's like a 33% chance, that's a higher chance, then shouldn't we like accept it?
Not rejecting मतलब ही तो accepting होता है. Not rejecting
Sorry,
H naught मतलब accepting H naught
that
होता है.
means we should reject it. Sorry, we should reject it. Sorry, that's so like
नहीं,
cause
नहीं, wait. So
fusion like
there is
formulas like
the probability that the test statistic will take a value more than more than 0.45 is 33%. You are saying that if this is the case, I should reject H naught.
yeah. Cause there's such a high chance it will be more than that. No, so like that's where my logic confusion. Like I'm getting confused in my logic.
Uh, नहीं, that's not how you are going to interpret it. So how do I put this over here? 33. So 9. Okay, take it in this way. For example, if you take some value less than 0.4 as well, है ना? Let's say you're taking 0.2 for instance.
Okay.
Tell me तो इसका p value कितना होगा? 33% से ज्यादा होगा या कम होगा?
30 but ज़्यादा.
ज्यादा होगा.
Yeah.
So that means, given my hypothesis, the more you move towards the left, जितना भी move करोगे,
Yeah.
p value ज्यादा होगा.
Yeah.
Correct?
Correct.
Okay. The more you're moving towards the left, the more you're moving towards 0, which is your acceptance point, right? Exact match.
Correct.
ठीक है? So the more you are moving towards exactness, larger does your p value become. ठीक है? तो more you are moving, तो in general if it is a perfect case, ठीक है, exactly तुमको actual में जो mean है, तुमको sample mean में भी वही मिला, then this is the point that at which you are, right? Test
Right.
statistic, numerator will become 0, so you are at this point,
Yeah.
right? Correct. So
Yeah.
the probability that x will be, अगर तुम x equals to 0 पे p value calculate करते हो, the probability that p is greater than 0 will be half, 0.5, 50%. correct?
Yeah.
So the closer you're moving towards the exactness, greater your p value becomes. p value का interpretation उल्टा है. You are trying to interpret it in this way कि p value जितना ज्यादा होगा null आने का chance उतना कम है. No, p value जितना ज्यादा होगा हम उतने ही null के करीब हैं. That is the interpretation.
Okay. Okay. Okay.
Okay, it is ulta.
Yeah. Okay. Got it. Got it. Got it. Got it. Got it.
Okay,
Okay, sir. Understood. Thank you so much.
okay. So that is the idea.
Perfect. Okay, sir.
All right. ठीक है.
Okay, sir. Thank you so much, sir. Sir, next class, sir, when are we
हाँ.
doing?
Next class Thursday. I'll have to see 9 or 10. You will be informed. ठीक है, right? You will. I'll ask them to drop a message. I'll have to see when I can manage, whether 9 p.m. or 10 p.m. Indian time. I'll let you know. Okay, you'll get the message on Thursday.
Okay, sir. And so can you like just send the notes like the last one also, sir? I think you accidentally sent the wrong one. Can send the correct one, sir, please.
Send the wrong one.
So like you sent of the first week, first day we did the notes.
हाँ, उसके बाद you haven't got it. Like, अच्छा,
No,
you
sir.
haven't got it from them.
No, sir.
Okay, ठीक है. I'll mail you.
Okay, sir. Thank you so much, sir.
Thanks. Bye.